Okay, we're going to start by going from one panelist to another, and they're going to give a little bit of an overview of their practice, so we have that for context. Robert, maybe you can start.
Thank you, Don. I'm Robert Thorgood, Hurley Palmer Flat. We work all over the world providing data centers for end users, co-location providers, and also for some of the larger hyperscale tech companies. It's a very interesting market that we are in today, so hopefully we can add some discussion today. I think the answer is yes, of course you do need design engineers, architects, a whole plethora of disciplines. It's absolutely essential.
What a surprise.
So Amy Daniel from ACOM. I lead the mission critical practice across EMEA and Asia Pacific. We are a multidisciplinary engineering firm, so I hope we still need architects, otherwise I've got a whole lot of people who'll be out of a job.
I'm Tom Blake from Arup. We've been in business for 70 or 80 years. We have offices all over the world. We've 14,000 people working for us, something like 40 offices. Started in the UK, right across Europe as well at the moment, across North America, Asia Pacific, and Australia. We have a large data center business centered out of London, and working all across Europe and also in North America. And we work for all the big cloud players, we work for the colo people, we work for a lot of enterprise type clients, so we see all aspects of the industry. So looking forward to the discussion.
Mark?
I'm Mark Seymour from Future Facilities. We are not a design company, and we provide simulation services to enable you to analyze your design. And I've been told multiple times since Future Facilities has been in existence that we won't need simulation anymore, a bit like we won't need design anymore because technology is going to take over, only to be told by the same people, now I understand why you're saying we need it even more than ever. And I believe that's the case for design of data centers, that automation, standardization of designs is taking us forward and might make you think you don't need design, but in practice we're trying to make data centers much more effective and efficient, and so we all the more need design to be able to make it work.
Thank you, Mark. So open it up to any one of you to explain what your thoughts are, share your thoughts on the changes that have happened in professional practice in the last 5 or 10 years. Maybe it hasn't changed at all. Maybe you're not a commodity. Maybe you're professional. I don't know.
Well, do you want me to? Shall I? Okay, so what I see in the data center world is that data centers are obviously getting much bigger, but also the design is becoming more standardized. So we have lots of clients who would come to us and say, we got this global agreement to buy all this kit, and we've got, we've purchased all this stuff, and what we want you to do, Arup, is pull it all together, and this supplier is going to do this for you, this supplier is going to do that, because we've got global agreements for this. But you're the designer, Arup. Well, I'd have to question whether we are the designer, actually, when we've made none of the major design decisions. So that's why I think the question is valid. I mean, who is the designer? Certainly for these types of clients that have a big engineering base, data center clients are probably the most informed clients you could have. They're perfectly capable of doing the design themselves. They're certainly capable of giving the direction for all the design decisions. So yes, it's a valid question. So that's my perspective on it.
Thank you, Tom. Amy?
I think as designers, we've got to remember that there are lots of different client groups, and so you've got the very informed cloud services providers, the massive hyperscales, the lead wholesale co-location providers. But then you have the new players coming onto the market who might have been telecoms companies before, so the way they're designing is very different. And actually that's probably where our expertise are needed, and that's where we're able to add more value to the design process to these clients who are trying to break into a market and do something new and innovate away from a standard basis of design that the cloud players will have.
Thank you. Robert?
I agree that there's a lot more standardization, particularly in the data halls and the way that they're put together. But with scale, either on the smaller side, if on the edge perhaps, or even on the hyperscale side, they present other problems, other issues. There's that of getting utility power or gas or water or whatever it is. You need to be able to make sure that you can actually get to fit the scale of the development. And that as you go larger and larger, that challenge becomes greater. And we're certainly seeing that, if you're trying to get 100 megawatts to a site, that presents the utility, whatever form it is, with a much bigger challenge. And the timing of that takes time. So you have to think of options as to how you might present the energy to the facility. And that is something you've got to work through and explore all the options.
So as far as a raise of hands goes, so how do we feel as relates to whether or not design consultants are basically in a commoditized service at this juncture? Is this the common way that design consultants are treated, or is it some other way? How many think that it's a commoditized service at this juncture? No one. I do. Okay, so then the second thing though would be, what do you think about the contractors, the construction people? Is that become more commoditized, or is that really a journeyman level thing and high quality and that sort of thing? What's been the trend as it relates to that area?
I think we're seeing more of the tier 2 contractors coming up into a main contractor space. So understanding that these are mechanical and electrically led buildings, and so why aren't they the lead contractor in the project? Why have you got a main contractor who's doing the bricks and sticks leading the project design? So I think that's a big change I've seen, is that the M&E contractors are coming up and doing more turnkey and taking ownership of the civil engineering element.
Good. Mark?
I think there are opposing forces on that question, because when you think about data centers that are being produced as pods and things like that nowadays, that's clearly commoditized construction.
Yes.
But when you go to the hyperscale or edge nodes, these bespoke systems that are being generated, they are creating these data centers to a very heavily tailored extent. So they're actually integrating the IT into the design of the building, which never used to be done.
Yes.
And the design for that building wouldn't work if you put different IT in it. It has to be redesigned almost when you do an IT upgrade.
Yes, yes. Good point. So on the, I would say that the world in general has become much more procurement dominated, and so that impacts everything, what consultants can do, what contractors can do. So, Robert, we haven't talked about this, but how do you feel? From my perspective, I think that the quality of the construction workforce has gone down. It's not, to throw a dart at them, but rather it's just this overall pressure in general within the industry, and then therefore it impacts the design consultants as well.
Yes, I think there is a limit to how much capacity the construction industry has, and the more and more you push it, inevitably the quality is likely to reduce. You can help that to some extent by breaking it up. So Amy's point about some of the tier 2 contractors picking those and selecting those for their abilities is much more important. As a design consultant, we can develop the design to a much higher level, to a deeper level, if you like, to make the job of the contractors easier. Although you can go too far and then take the ability of the contractor to make his money, which he needs to do as well. So there is a balance between the two, and we have to be very careful.
Tom?
I think, as Amy said, the industry is a broad church, really. There's lots of different sectors to it. Certainly there is a movement towards the contractor becoming the most important member of the whole construction team, taking on the design, managing the procurement, managing the client, managing the fit out. And it tends to be driven by risk. No one wants to take on the design risk. There's a huge risk associated with design. And sometimes I think that's the only reason we're involved, because there is such expertise in all the other parties to a data center project. that someone has to take on the risk, and therefore, and the contractor is an obvious candidate to do that.
Yes.
And that's why they're becoming more important. That's why we work for contractors as often as we work for the client.
Yes. Amy?
And also, when you're actually, so the question, will the design consultant be needed? Actually, as the construction industry is being stretched, you're going to need us more because we'll be more heavily involved throughout the construction process to make sure that the designs are being adhered to by possibly a workforce who are not that skilled.
Yeah, there is a movement as well towards compliance and someone signing off. You know, even if you're not the designer, you're signing it off as being in compliant with regulations or the client's requirements. So that's another change in the role we're carrying out on projects.
And so what would you say as relates to the trend regarding codes and regulations? Are they becoming more complicated, less complicated? What do you think about those things? The building codes as an example.
There's certainly more information that we have to hand over during the process and right at the end of the project. There's far more that, I mean, you just go back 10 years. You had to produce quite a lot of information, but now it's even more and more, particularly on the energy side, proving that you are meeting all the requirements in whichever country it happens to be.
This industry is so ripe for further regulation. As Robert said, a 100 megawatt site now is not, you know, it's huge, but it's not unique anymore. And that amount of energy just has to be regulated in some way. So we can expect more, more and more of this type of regulation.
But I have to question how effective it is being, this regulation, because a lot of the performance is not down to how it's designed, but how it's operated. And so
Yes.
how much should we be seeing designers taking a follow-through role in ensuring that the data center is operated in the way it was intended? What should be being provided? That would be my question, because I feel that's being missed. The regulations are all about hypothetical performance rather than real performance.
And also,
Yes.
some of the regulations that we have to adhere to are completely bonkers for the buildings that we're designing. So if you've got to say, right, you need 300 car parking spaces on this site. Well, at peak occupancy, you're going to have 35 people operating it. So why do you need 300 car parking spaces? When you're looking at fire regulations and the way you'd manage fire in a building like a data center, you are not going to go in and fight. You are going to
Yes.
let the building burn to the ground. And so when you talk about smoke extract systems, completely non-applicable to a data center, but so many of the codes saying that you need to have smoke extract systems in those buildings, but you would not go into a burning data center.
Yes. So maybe just for me to comment on that particular area, fundamentally the code officials, they need to protect themselves. And so therefore the codes in general are developed in a prescriptive way, not a performance way. And it's really hard to have regulations that are performance-based because it involves some sort of qualitative, in addition to quantitative basis. And so therefore you could argue that what is going on is maybe there's a different emphasis within design community, design consultants, and therefore maybe a larger part of their role has to do with the complicated navigation through the regulations. And as Amy said, the fact that there's going to be 10 people occupying and you need 50 parking spaces, how does that make any sense?
Yeah.
So it's really like being a pilot or navigating through. What do you folks think?
I think it's not design. I think there's a role there for a consultant, a compliance consultant or specialist to steer a project through all that maze of regulation. And that's probably someone with a designer's background.
Yes.
Yeah.
If you look at firms like Tech UK and the way they're trying to influence governmental policy and actually educate legislators on how they are prescribing what we need to do, and that's, as an industry, we need to be getting those people more involved in what our buildings do and what they need to do so that actually they have a more lenient approach to allowing us to design them the way they're intended to be
Yes.
run.
I think Mark's point about how you operate the data center is a very valid one because many of the data centers we've designed and then handed over are then operated for some considerable time, so 6 months, 12 months, maybe longer, at very low loads. because it takes time to build and to deploy the technical equipment inside. So we as a strategy now produce a low load strategy document which says what you should do to the operator if you've got this load, how much plant you should have on, what you can turn off, because turning off is actually a very good thing in many cases, because you can actually help your energy consumption considerably. But people won't do it unless somebody's actually defined it exactly what you should do. And it's now, automatically, we now produce those sort of documents to inform the operator as to what to do.
So I think that's also very interesting, because that's a piece that's not really part of the regulation.
No.
So if you take a subject that's close to Don's heart, which is 90.1 and 90.4, in the US, we got regulation because there was a vacuum for any sort of regulation, which was then objected to because it wasn't applicable to data centers. In the application of 90.1 to data centers wasn't really appropriate. And so 90.4 came in, which has only caught the very lowest hanging fruit and actually not really pulled the standard of data centers up. In fact,
Hurts
most
design.
data centers are leading.
Yes.
So it's just catching the very, really bad ones that really ought to be caught anyway. So I'm not sure that actually that regulation has really been very effective in terms of improving the industry. The industry is doing self-regulation in terms
Yes.
of improving the industry.
Yeah, as you know, Mark, I'm ASHRAE, so to speak, and I was totally against 90.4. And fundamentally, back in the day, I was vice chair of 90.1. And when we started TC 9.9, the focus was not to do a standard. It's too slow. The data center is changing too fast. And so the thermal guidelines from ASHRAE, that's the de facto standard. It's referenced all around the world, and it was not a consensus. We pooled people, but not a formal consensus, which would take years. We've already revised it 3 times and done it really fast. And part of the problem with the regulations is it doesn't fit, as Amy said, and the level of change is really difficult. And so part of the things I think we're saying here is that the design consultants, we could say that it's self-serving to say we're going to be here forever, that we just know and nobody else knows. But it's just that fundamentally, one way or the other, a licensed professional is a licensed professional. When it comes to the filing side of things, there's no way around that. It has to be done by a licensed professional. And the codes are really changing to solve different kinds of things, global warming and all these different things, each of which has an impact on design. And those types of things typically aren't known by the owners. Even if they have design capabilities in-house, they're not strong in that particular area. Does anybody have any questions they want to ask before we go ahead and do more talking? Oh, no.
Can you repeat the question?
No, I can't. I couldn't hear it well enough. It was...
I think the answer is because it's being client-driven. You've got clients who have got to adhere to SLAs of various things, like the banking industry. They're not going to let the data center run as hot as ASHRAE is saying it can run. So it's a client education. We as consultants need to be educating clients. At the moment, that's why we're still doing it. It's been client-driven.
I mean, 100 megawatt data center just does not make sense in Europe. You shouldn't be cooling them. Nowhere in Europe with Class 3 servers do you actually have to do that.
Oh, now I understand the question. Right, so I think I finally heard what you're saying. So all you're saying is that because of the climate, we don't really need to be putting these cooling systems and things in. That's what you're saying. Well, so this is where I think the industry, to some extent, is better at regulating itself than regulations are, because they have to manage the risk to their business against the cost of running it. And one of the problems here is that the cost of running the cooling system is actually not that big compared with the risk to the business. So I'm not saying it's a small cost, but compared with the lost business in some industries, it can be a small cost. So people do tend, because of the lack of education that Amy's talking about, to think, oh, well, I'll play safe and then we get systems installed when they're not really, they're probably not needed, and we could be using free cooling and things like that. So I think the industry, with education and self-regulation, would probably be more effective than trying to apply regulations which are difficult to impose in each different application.
Yeah, if I could just add to that, ASHRAE isn't a regulation, it's a code. And if you look in the appendices, it tells you what the risk is. Isn't that right, Tom?
Yes, that's true.
Yeah,
So-
I wasn't commenting on ASHRAE,
Yeah.
but yeah.
So just a context or counterpoint. This podium, if it was full height, it's about the size of a rack. If it's 10 kW, that's equal to the heat of a fireplace. If it's 30 kW, it's the heat of 3 fireplaces. So if we design a data center today for 10 kW per rack, and it comes out to be 30, 5 years, 10 years from now, how do we go ahead and deal with that? And so part of the issue in design is how do you not over-design, but at the same time future-proof? And the form factors have really changed. So if we think about it, since we've all been in the business, you had before towers, right? Computer towers on your desk. And then there were one-use servers, and then there were blade servers. Who knows what the next format factor is going to be? That's all part of a design consultant's responsibility, is to understand the variation that could happen in form factor and these various things. Robert, you want to
Yeah,
weigh in?
I think what's interesting over the last 10 years is that we've moved from end users towards co-location, towards hyperscale or technology companies. And in that transition, we've moved from being risk adverse, highly risk adverse, particularly with financial companies, into co-location where there was risk, there was a little bit more leeway, but as Amy says, they had to meet SLAs, so they were always on the back foot slightly. But now we've moved into the big tech companies, bigger scale. The risk has, I wouldn't say disappeared by any means, but you're able to move and use the ASHRAE code to push all of its boundaries. And so that's why majority, certainly in parts of Northern Europe and Ireland and so forth, we see now these hyperscale facilities which are nearly all fresh air based, and they really are pushing the envelope. And there's no reason why not, but you would never have found a financial institution doing that 10 years ago.
The thing is as well, so Google in their Finland facility don't cool at all, but if you can't get onto Google on your phone or whatever, you don't blame Google for that, you blame your internet service provider. If you can't get onto your Barclays banking, that's a whole different situation. And so it's looking at the different
Depends.
people. Yeah,
Depends on the
exactly.
application.
Yeah.
Yeah.
Just
Tom?
to paraphrase Robert, in defense of 100 megawatt data centers, putting all that kit in one data center and applying the technology that Robert is describing is much more efficient than having 10 or 20 small data centers in a colo space. Trust me, it's much better for the world. It's much better for energy consumption.
In any event, I think that the issue there is the fact that the large cloud companies had a centralized model. They had a centralized model, really big stuff. And based on edge and the things that are going on, they need to switch to a combination of centralized model, still for this big compute, and a distributed model. So there's a bunch of little things going on at the same time. You see a lot of things going into the colos. And the colo companies are really confident that they can oversubscribe, otherwise known as playing Russian roulette, because when the cloud guys are in there, they're going to draw the full power, and there's going to be hell to pay.
I think we're in great danger when we talk about going to fresh air data centers, convincing ourselves that we've suddenly become super efficient, when actually there's still a lot to do. So we can still save a lot of energy by looking at the IT itself. And it was mentioned earlier that turning it off is a good idea, but actually just low power sleep states, et cetera, are not utilized enough in the equipment that we choose. And if we choose that, we're going to get much, much greater savings by looking at that, and also making sure that we're making good use. It's all very well if we create all these big data centers, but if we only partially occupy them and then build another 3 because either we've run out of space or we're just not happy because of hotspots or whatever, then we're still wasting a lot of energy indirectly in the construction costs, in all the embodied energy and things in the data centers. So there are lots of ways we can still improve way over and above just going to free cooling to get an energy efficient data center.
Any other questions? Yes. I waited till you went to the back.
Hi.
Mean American.
One question that was raised earlier is actually, well, yeah, fresh air cooling is nice, but we're blowing out heat, and that's just blown out. And saying we are now energy efficient because we're blowing out 100 megawatts of energy into the free space and not looking at what to do with that, I think that's a major mistake.
Yeah,
as well.
so that's obviously a classic situation of there's a lot more to do, because we could be reclaiming that heat. And it's done a little bit in Europe, particularly, not so much in the US, in district heating systems and things, reclaiming that energy. The problem with most of the energy is that it's currently low-grade heat, okay? So it's low temperature. Liquid cooling obviously provides the opportunity to increase the grade of that energy and be able to reuse it. But I think it still comes back to the management of your data center, whether you're willing to manage your data center to be able to reclaim it and have a balance of a business of reclaiming heat against the business of running your core business. And this is all about really the predictability of your business. And the same applies to how you operate your data center. You need to understand what it's going to do when you make certain changes. Will you be able to support that external requirement for energy, etc.? It's a difficult decision for a business to make.
Not saying it's easy, it's just, I mean, blowing out 100 megawatt center will always have some heat that it needs to get rid of. It's not going to be cool. But if you have the opportunity, of course, there's another revenue stream possibly even there.
Well, it's not all blown out. A lot of it is recycled, and the supply air is tempered. A lot of it gets reused. People shouldn't think it's all wasted. So there is elements of it reused. It is the big challenge for the industry. I don't know if we can't solve it yet, because the heat isn't good enough to be used elsewhere or transmitted or transported elsewhere. But it has to be solved. It has to be solved. Yeah.
Heat transfer basics. Any other questions?
Just before we move on from the heat recapture, what use cases have you guys seen? I mean, outside of the Nordics, is there any use for that heat that comes out of data centers, like taking the UK and Ireland and the Pacific? Like, what temperature does it need to get to? When does that become useful, and where could it be used?
Sorry, I didn't quite catch the question.
The question was, what are the use cases whereby you can use that second-grade heat to do things?
As Mark said earlier, the biggest problem is the heat that's coming off is 35 to 45 degrees. It's very low grade. It's difficult to capture. It's difficult to use. I think, particularly when you're looking at a much larger scale, the other aspect you have to look at is by going fresh air cooling, you've reduced your PUE, hopefully, to a very low level. We've been concentrating as an industry on that point whatever to make that as low as possible. What we haven't really looked at is how do you reduce the one? So the one is the technology. So how do you produce your energy for the technology in the first place? And I think we will have to look at, and in fact it's discussed yesterday, we have to look at how you generate your energy on the site, whether it's gas-based or other fuels or fuel cells, but because in producing that energy, you often get a byproduct, which is useful energy at high temperatures and could be used in district heating systems or even cooling. Certainly when we've done work in Sweden, you're bound to provide heat or cooling into district cooling systems.
But the answer is that there are plenty of applications. The question was too generalized. So as soon as you ask a generalized question like that, people are thinking about large data centers. What about a data center that's in a rack, a single rack, and it's producing heat, and there's a need for that heat that's 3 meters away? Perfect. works really well. So the edge computing and all the different things that are going on, there's all different size data centers, as Amy said, different applications and so forth. So if we look at this big district thing, we got transport factors and all kinds of things that are complicated, really reduce the capability to, or the opportunity. But at that smaller scale, in some cases, it's really easy. It can temper the domestic hot water, or it can do all kinds of different things. So it just depends. And we're out of time.
We are. So thank you, Don, and thank you to the panelists.